Hello and welcome to the Supermicro 5G Live Forum. I am Malyala, Senior Vice President of Field Applications Engineering and BizDev for Supermicro. Supermicro has made significant investments over years in expanding the product portfolio based on application-optimized server building blocks to address infrastructure needs from core to edge. This makes Supermicro a very natural fit in 5G infrastructure based on x86 architecture. One of the fundamental components of 3GPP 5G core infrastructure architecture is the user plane function, or UPF. UPF represents the data plane evolution of a control and data plane separation strategy. Supermicro, Intel, and ASTRI have worked together to create a 5G core UPF reference based on Supermicro's award-winning BigTwin product line. It's my pleasure to invite Alex Mui, Director of Software from ASTRI, Chandresh Ruparel, Director for 5G Core and Infrastructure from Intel, Terence Nally, Global Wireless Segment Manager from Intel, Bill Chen, Product Director from Supermicro, and Michael Ocampo, Product Manager from Supermicro, to represent the UPF reference and technology behind it. It will be followed up by a panel discussion. Without further ado, let's have our presenters go over the 5G core and UPF reference, starting with a video and presentation of BigTwin, followed by Intel and ASTRI on the solution.
Supermicro X11 BigTwin now supports Intel's second-generation Xeon Scalable processors as well as Intel Optane DC persistent memory, adding more capability to the industry's most flexible 2U multi-node platform. With its no-compromise design and resource-saving architecture, the Supermicro BigTwin features high-performance storage options like all-flash NVMe, as well as flexible high-performance networking choices including 100G Ethernet, InfiniBand, and Omnipath. The BigTwin supports up to 4 hot-swappable nodes in a 2U form factor, powered by Supermicro's unique redundant power stick technology, up to 2600 watts. By efficiently sharing power and cooling across multiple nodes in a compact form factor, unique resource savings are attributed to reducing TCO. Each node supports dual processors supporting the entire range of second-generation Intel Xeon Scalable processors, up to 205 watts TDP, up to 6 terabytes of DDR4 2933 MHz memory and 24 DIMM slots, including support for Intel Optane DC persistent memory. Storage options including all-flash NVMe, hybrid NVMe, SAS3, SATA 3 drive bays, and dual internal NVMe SATA M.2 SSDs. 2 PCIe 3.0x16 expansion slots, an SIOM slot for flexible networking options including 10G, 25G, and 100G Ethernet, EDR, InfiniBand, Omnipath. BigTwin is optimized for enterprise-class total solutions such as hyperconverged infrastructure, software-defined storage, and high-performance computing that require high availability, performance, and density. For more details on the Supermicro BigTwin, please visit our website at supermicro.com/BigTwin.
As you see in the video, BigTwin is a 2U multi-node system that doubles the density and have higher power efficiency compared to the 1U rack-mount server. It offers many storage options to meet the requirements for different applications, from 3.5-inch spindle hard drive, SATA SSD, to U.2 NVMe or EDSS E1.S. Other than the front half-swappable storage drives, in the motherboard slave, Intel Optane DC PMM, the persistent memory, can be populated on the memory slot as the storage cache. With a M.2 adapter board, 2 M.2 devices can be used as a boot drive. You can install an OS or hypervisor with a RAID 1 to these M.2 drives. About the onboard networking, the BigTwin system uses SIOM slots to offer flexible networking selections from 1G to 100G Ethernet or InfiniBand. Other than the SIOM slot, there are 2 PCIe/16 slots connected to the different CPU, which means that each CPU has 1 PCIe/16 slot for I/O expansion. It is good for applications that requires the balanced networking. BigTwin is a powerful, flexible, and highly serviceable 2U multi-node machine that can fit in different use cases such as HPC, high-performance computing, HCI, hyperconverged infrastructure, CDN, and much more. So later, Michael is going to share more information about it.
Thank you very much, Bill. Hi, everyone. Thank you for joining us today. My name is Michael Ocampo, and I am the product manager of the BigTwin product family, and I'm very excited to tell you about our 5G UPF reference architecture. We've been talking to operators and partners who are looking to add additional services in a cost-effective way, of course, to deliver infrastructure capabilities to really address this traffic growth within our telecommunications network infrastructure. So this is the reason why we have invested our time and engineering resources into the user plane function, because it is a fundamental component of the 5G core infrastructure and mobile technology. According to ABI research, the 5G infrastructure revenue is forecasted to reach about $26 billion by this year. And within the next 4 years, that's only going to grow by another $8.4 billion. So this is the reason why we've worked very closely with Intel and ASTRI to use our system in a way that helps accelerate 5G applications with Cloud-Native UPF with the help of Kubernetes and a data plane development kit, which is very common in the industry. So because of the partnerships that we have with Intel and ASTRI, we were able to achieve record-breaking performance of 1.34 terabits per second for the 5G UPF. Now, this is an industry benchmark for enhanced mobile broadband performance, or EMBB live traffic, and we're able to achieve this with 16 CPUs in a 4U configuration. So as Bill mentioned earlier, our BigTwin system architecture is a no-compromise design. So each subsystem has 2 CPUs, and each one of the CPUs is paired with a 100 gig NIC card based on Intel 800 series. So if you take a look at the performance overall across the 8 subsystems, that's how we're able to achieve 1.34 terabits per second. Now, if you take that number and divide it by 4, that's the performance per 1 RU, which is what the industry is taking a look at here in the chart to compare against what has been submitted before. So last year was about 100 gigabits per second. Now we're at 335 gigabits per second. So it's a major incremental increase within just 1 year time frame of about 3.35 times more. So here's an overview of our bill of materials. As you can see, there are 2 BigTwins in this reference architecture, and it is our all-flash NVMe model, which are all hot swappable. So this is a major advantage for data centers that are wanting to have that ease of serviceability for NVMe technology. Again, we were one of the first ones to bring this technology forward, as well as the twin architecture systems back in 2007. So we've innovated and incrementally improved the technology and density for our twin systems. And today it's still one of the most powerful and high density solutions in the market that are all isolated subsystems. So you can see here that each one of the nodes actually has its own dedicated SIOM or Supermicro IO module to handle the session management function. And then for the data path, we're actually using the 100 gig NIC card or the Intel 800 series to basically help identify and steer traffic. So the CPU that we use is the 6230N, which is the 2nd generation Xeon Scalable processor. So that is helping to really drive the performance, and with the help of Kubernetes, we're able to keep all those cores busy. And because of the amount of memory we have, we're able to help prevent context switching for this simulation. We actually only use 12 DIMMs, and our subsystem actually accommodates up to 24 DIMMs. This is the cream of the crop and best of class of the form factor for the 2U4 node. We have one of the largest real estates for memory in the x86 industry. So that is one of the reasons why we're able to drive this performance, is because all of these factors are all working together in harmony to basically streamline this pre-processing and able to drive the throughput in aggregate across all of the 8 subsystems. So here's more information about the NIC card itself. The Intel 800 series supports application device queuing, which helps with the queues and steering of the traffic. And this is a fully programmable pipeline, which supports DDP, or dynamic device personalization. And these profiles help to configure the packet processing pipeline to support a broader range of traffic types. So the card itself supports RDMA over converged Ethernet, which is a very important aspect of the system design because our system has one of the largest memory footprints, as I mentioned earlier. So the NIC card is able to work with the CPU and memory banks to basically help to predict and improve the latency and ultimately overall throughput by filtering application traffic to dedicate a set of queues. So the concept on the right is illustrated where you have a freeway full of cars and a traffic jam. And when you do not have dedicated lanes, it's a chaotic system. So therefore, the cars are moving slower. Whereas when you have dedicated lanes, like a carpool lane, then those lanes can move faster. So if you think about that conceptually for application traffic and you're setting up dedicated lanes, that's how we're able to improve the throughput for specific applications. So here's a high-level overview of the core mapping of the Intel 6230N across all 8 nodes. And what we're trying to illustrate here, if you just take a look at node A, we're trying to illustrate how Kubernetes is set up on just one node. So within the node, of course, there are 2 CPUs, and each one of the sockets or CPUs, you have a dedicated core that is paired with a 100 gig NIC card that is handling the operating system, the Kubernetes engine, and the selectd, which is helping with the telemetry and real-time monitoring. And then you have another core that is dedicated for the PFCP, or the port forwarding control protocol. And then 17 of the worker threads are dedicated for driving the performance. So within that socket, you've got one UPF pod that's able to support about 65,000 subscribers. So in aggregate, you're looking at about 1 million subscribers. So that's an unheard of number in performance of 1.34 terabits per second for such a high density configuration. So here's a diagram to help illustrate the 5G core infrastructure, just so the general audience understands where the reference architecture or BigTwin solution could potentially fit. So currently, there's a lot of pressure on the core network. So what operators are trying to do is not only bring infrastructure closer to the end users to improve the latency and experience, but it's also to help offload the core. And that's a major component of the business and industry wanting to create a 5G infrastructure to help offload and distribute this incredible amount of data that's being requested of the network. So this creates a tremendous opportunity for us and our partners to really enable operators to deploy this type of solution with x86 commodity hardware. And we're doing it in a way where it's very high density, very cost effective, and with common tool sets with the DPDK and Kubernetes, which is ubiquitous now, especially for customers that are working with mobile applications. So we're working very closely with other software partners, and we're able to address this fundamental challenge for the infrastructure together with all these partners to basically help provide a faster, low latency sensitive infrastructure to essentially provide a more cost-effective gateway function between the edge and the data networks as the mobile network traffic continues to multiply. So to really help demonstrate the solution, we've actually received a video from Intel that shows a real-time dashboard of the throughput. So that is the next video that we're going to show right now.
Hi everyone, my name is Terence Nally and I'm the Wireless Core Segment Manager at Intel. Thank you very much for joining us for this virtual conference. While the transition to 5G is in the headlines now, Intel has been optimizing mobile core workloads in virtualized and cloud environments for the last decade. developing and exposing hardware technologies, and working with the industry to optimize software on our processors. The installation of new infrastructure is expensive, and in the telco market, the infrastructure must be utilized as much as possible to maximize the investment of the communication service providers. For this reason, traffic density, or maximizing the throughput capacity of traffic over the network, has never been more critical. In Q1 2020, Intel and our partners are demonstrating a groundbreaking 1.3 terabits 5G UPF throughput of enhanced mobile broadband traffic, all on cost-effective Intel Xeon Gold processors with headroom to spare, while also providing the scalability to increase CPU core count, frequency, and NIC throughput for even greater performance. The solution demonstrates a dense deployment of standalone 5G UPF based on ASTRI's 5G core stack, optimized by Intel. This is deployed on two Supermicro BigTwin servers using second-generation Intel Xeon scalable processors with Intel Ethernet 800 series 100 gigabit NICs. The system is container-based and orchestrated by Kubernetes. Telemetry is via CollectD. As you can see, this shows not only groundbreaking throughput, but the deterministic end-to-end latency required to deliver advanced 5G services. The new Intel Xeon processor product family is ideal for next-generation virtualized and cloud workloads. Higher core counts, enhanced virtualization capabilities, and increased memory bandwidth provide the resources to drive these improvements in performance for a wide range of telco workloads. The 800 series NICs employ Intel's dynamic device personalization to parse very deeply into the packet and steer traffic based on data from the inner header fields. Thank you for your time. If you'd like to follow up with us about this solution, or if we can help assist with other 5G and networking topics, please do not hesitate to reach out.
Now, turning to the panel discussion, due to the time zone differences, we have a pre-recorded Q&A with Alex Muey from ASTRI related to the industry, software stack, and industry standard solutions. So Alex, thank you for joining this panel, and really appreciate the collaboration that ASTRI has done with Intel and Supermicro. But I wanted to ask you a couple of questions, and maybe you can give some guidance on how this solution is applicable and how people can consume it and whatnot. So if you're okay, I'm going to ask you a few questions.
Sure. I really appreciate for Supermicro to invite me to join this event, and I'm glad to talk about these exciting things with you. Thank you. Please go ahead.
So I was looking at the previous presentation here, and the performance of this solution looks spectacular. So I was wondering, how did we get this kind of results, and what do you make out of these results?
It requires a lot of R&D, and in the process, we spend a lot of time optimizing the hardware. And in fact, in order to do so, hardware and software optimization will be required. We have spent a lot of time in optimizing the number of packets being processed by each CPU core, and then a capability to allow linear scalability when we scale up the number of CPU cores to achieve a very high throughput.
Historically, telco providers often consume products that are more proprietary. Recently, we have seen people taking, for example, NFV type of applications where they are going with industry standard architectures. So do you think it's important to adopt open standards, and how the Supermicro, Intel, and ASTRI, the work done together is going to help them on that front?
Yeah, definitely. Having an open architecture is really important because 5G allows a very flexible deployment. As I said, you can have control user plane separations. You can deploy it in different places. You need to optimize in terms of different latency and throughput requirements. That means no single vendor or single product can actually handle all these cases. So by all means, multi-vendor will definitely be the trend. And having NFV makes it's more easy to manage, more easy to deploy, and also It allows more flexibility. For example, in the past you need to have wires to be changed in order to switch its topology. But with NFV, you can simply using software like the orchestrator to orchestrate everything without doing many hardware setup. That will speed up the 5G deployment and also reduce the management complexity. So I see that the 5G having the NFV and cloud-native architecture would definitely help the operator to deploy 5G and also enable applications on top of it.
So Alex, the performance of this BigTwin with Intel content and with ASTRI software running on it, the performance looks phenomenal, right? So number one, is this kind of performance needed for the customers, or can they get away by using something that is much lower end? And second thing, how do people make use of ASTRI software, and how do they get access to this? What is the value that ASTRI can bring to the customers?
Okay. For the first question, the value of this is really phenomenal because with 5G, we can imagine the traffic scale can go up very, very quickly. And with the 1.3 terabit per second, that kind of throughput, it can sustain a tremendous growth for 5G. And in terms of the backhaul, we can imagine that we cannot easily build up a network physically to support a very high throughput. That means with a 1.3 terabit per second taken off capacity, it can consume the data traffic or provide the data traffic locally from this platform without having a very high backhaul cost. That would be beneficial. On the second question, how ASTRI can help. We can help in different aspects. First of all, we can provide a software to build different kind of deployment situations. You can deploy on premise. You can deploy in a distributed manner. The second thing, we have a orchestration capability that allows you to do what we call sort of like a zero-touch capability. That when you deploy an edge UPF, you don't need to have a local technicians to be highly skilled in order to perform that operation. Everything can be done and managed remotely using a centralized orchestrator. That's the second point. The third point is this architecture actually fit into a cloud-native architecture. What it means is all the logs, all the metrics, we're using standardized or industry standards like ELK, Elastic, and so on, that allows the operator or the users of the network to collect statistics, not only for the 5G core, but also the platform and other parts of the NFV infrastructure that allows them to do a more deep data analytics of how this platform is performing, and then make decisions on scaling in or scaling out more effectively. So these are the benefits that we can bring. Of course, ASTRI is an organization that provides licensable 5G core software that allows others to build product as well. So people are certainly welcome to talk to us in terms of how this enables the solutions, how it enabled architecture, how it enable easier manageability. So thank you.
Got it. Thank you. Really appreciate it.
Thank you.
So Chandresh, from Intel perspective, where do you see the 5G going? Is 2020 the year of 5G, or where are you seeing the adoption for this one?
Thanks, Rick, for the question. As we look at the 5G standard getting completed and implemented, in fact, the momentum is picking up really well. And absolutely, as you mentioned, 2020 is the year of 5G core deployment. Right? So what you're seeing is that 5G on the access side has already started deployment with NSA core, but SA core is what's now taking really solid ground. In fact, IHS recently conducted a survey, and what they found is that 20% of the carriers are planning deployment of 5G SA core this year and 47% next year. So you're talking about almost 67% of the carriers looking at deploying the SA core within the next 2 years. So certainly, it's really on a very strong moment.
Wow. But I mean, one of the biggest things in this case is, how do we even, deploy it, and what can be done to make it easier? It's perhaps more a question for Michael.
Yeah, that's a great question. Let me answer this in two parts. As you heard from Alex with ASTRI, we're working with them to help deploy cloud-native tools, but one of the fundamental challenges is provisioning the software piece first on new systems from the core all the way to the edge. And this is why we've invested more and more resources into validating cloud computing software like VMware or OpenStack, which has been discussed in previous topics, as well as container orchestration software such as Red Hat OpenShift and Kubernetes. And in addition to that, to help with the infrastructure management, we're building in more intelligence into the BMC to help with auto discovery, provisioning operating systems, and monitoring health metrics in a secure and seamless way with our own tools as well as REST APIs.
I see. So, this is like across all the platforms. I mean, I know that BigTwin has been, a great platform for multiple type of, workloads and whatnot. But does it extend beyond BigTwin? So, Bill, in your opinion, where do you see the infrastructure needs are going to be for 5G infrastructure?
Okay, so actually the 2U multi-node server, just like a BigTwin or Twin Pro, which are deployed to the 5G, or we can say the telco market broadly already. So I think it's not just provide the high density to save the space. I think it's because we have in terms of the structure, the architecture, you can save have a better power efficiency design, so that can save operation cost a lot. And also because all the modular designs, we can see that the hot swappable, hard drive, power supply, and also the computing node. So we can help the service guy to do the serviceability much better. And also right now the Twin family, we have a different cooling optional, can support a higher voltage of CPU and other and also we can, based on the different environment, for example, in the telco market, you need to have a higher operating temperature. Then based on the different configuration, we can make it happen.
I see. So density and configurability aspect of it comes into a big play with efficiency. So Chandresh, I think you are very actively involved in running these benchmarks and making it work. 1.3 terabits, which is pretty massive, right? Is something like that even needed? I mean, what kind of, is it good, bad? I mean, what exactly the big deal about this?
So I think that's an excellent question. It's not just about shooting through the roof of performance, right? I think as Bill and even Mike alluded to, I guess the new transition is complex for the carriers. It will require, or it is requiring rather, cloud-like implementation, ensuring that the total cost of ownership is really coming together for the solutions that they are deploying. And this is exactly where Intel has spent quite a bit of time and significant investment with ecosystem to ensure that we are enabling our partners with optimal solutions, right? So this optimization is very important because that doesn't mean just highest performance, or it's a combination of features, capabilities, cloud-like agility, the cloud-native implementation, and how you're helping your ecosystem do it, right? And this is exactly where we partner with Supermicro and others to make sure, and the ISVs, to ensure that the software and hardware combination delivers the best performance. Now, what's the significance of 1.3 terabit here? If you look at the traffic models that are being published in terms of forecast, obviously with the number of connected devices, monetizable use cases, we are expecting significant increase in traffic and the data that will need to be computed, that will need to be moved and stored. So it's not just about traffic throughput, but it's also, is your network really efficient, not just agile and flexible, but really performant in its ability to do it. And what we have proven through this exercise is that you can have a really efficient and with much better, much strong improvement in the total cost of ownership for the carriers. And that has, that's the theme here. So the way this has been created, framed, and optimized with the right hardware design, with the right software implementation, I think this should show the carriers the massive benefit as they go from their existing infrastructure to the 5G infrastructure.
I see. So I think this could be, a question for anybody. With the second generation Intel Xeon scalable processor family, kind of having a wide range of processor cores, frequency, all the other cool stuff. Now you're talking about improving the efficiency on the networking side by using the brand new network controllers. But what about the memory and the storage aspect of it? I mean, we hear a lot about DC persistent memory. Is it important? I mean, how does this whole thing come together in this?
Yeah, that's a good question. Go ahead, Chandresh, do you want to take this?
No, please. You just started. I thought it was, please go ahead.
Well, in our lab, we've been actually doing a lot of testing with Intel Optane DC persistent memory and working with our customers. And we found that app direct mode can actually help accelerate databases and can potentially lower the total cost of ownership. With that said, our reference architecture could actually benefit and actually have a dual purpose in the 5G core infrastructure. So number one, as you've seen, is to really manage the UPF, but number two could potentially be to provide real-time analytics in order to help streamline queues, reduce latency, and maximize the network layer, right? And in addition to that, reboot times can be 100 times faster when you take into account the rebuild time for quality of service, class identifiers, but this is significantly reduced with the persistence of Intel Optane DC persistent memory in app direct mode.
I see. So, I mean, we're talking about, one thing that I have seen common in all of your comments is the need for efficiency, need for, the performance and ability to manage it easily in the field, right? As people are trying to deploy it, how easily we can make it. So, Bill, Supermicro being kind of a leader in green computing and working with industry leaders such as Intel in this case, where do you see this efficiency comes into picture, for the 5G core infrastructure?
Yeah, I think we say that we keep IT green with this slogan for a while, right? So actually we continue doing this to improve the you mentioned that the power efficiency and also have other to save the total cost ownership in terms of the energy side. And actually we do a lot of different investment on this section. For example, we continually increase the power supply itself, the efficiency to have for example, right now we have a titanium power supply. Most of our power supply are in the 96% plus efficiency. And also we, in terms of system architecture wise, we also have a better architecture to increase the overall power efficiency, not just power supply itself, right? And also in terms of the structure I just mentioned, we other than the power efficiency, we also do some disaggregate design. So like a BigTwin or Twin Pro, we also have we so-called a modular design. So some component or some material, for example, the hard drive, you want to keep the original generation And right now you have a new generation for Intel CPU, then you can simply just swap the computing module into the BigTwin system. Then you can continue using the original hard drive you have to save a lot of material. You can keep the current generation to the next generation, so you don't need to store away those components. So we can save a lot of e-waste. That's the other word, right? So that's what Supermicro continue doing to keep the IT green, and we claim that we are doing the green computing.
So we don't necessarily need to change the entire system, and perhaps the 800 series controllers, if you were to just change it, and then you can have the latest on the networking side also. So Chandresh, you kind of alluded to something about the whole ecosystem development, right? So obviously it's not a single company that can do the whole thing. It's a huge effort. So can you elaborate a little bit on where this partner ecosystem is at this point, and how much effort is there needed in order for it to kind of become more mature, given that 2020 2021 is like right now we are in 2020 already.
In fact, the ecosystem is already in place for 5G deployments. In fact, that's how some of the leading carriers are rolling out this year. As I mentioned, over the last few years, we have invested significantly into the ecosystem to make sure that not only they're delivering commercial solutions for 5G core and edge, as well as access, but also they are optimized so we have the right configurations at a platform level, working with partners like Supermicro, that we have the right best practices from a software perspective that are implemented for optimal performance. And we have been basically, even without the need of any specialized acceleration, we have been able to standard off-the-shelf servers have been able to deliver significant performance in the 1.3 terabit. It's just another example of breaking, basically proving to the world that from a efficiency perspective, from the ability to handle traffic, I think the current infrastructure, just standard servers, is there basically, and that's how it's being deployed today. But to answer your question, I think not only the ecosystem is ready, we continue to invest further. We have an Intel Network Builders program, which is fairly broad, and it promotes not only existing vendors in terms of hardening their solution and work with them very closely, including deep technical collaboration with them, but we also invest in new innovative and disruptive technologies as well, so that the new monetizable use cases can be realized.
Great. So if each of you were to give a message to the audience, what would that be as a parting thought?
I'll start, I guess, Vic, since it's the last one to talk, I guess. I think 5G is here. There is already strong momentum, both on the access and the core side now. We are seeing the proof point. I think the carriers are chomping on the bit to now try new monetizable services and bring forth the promise here. So cannot be more excited. And I think the industry at the same time is sort of on a high gear right now. Driving forward.
Yeah.
So Bill?
Yeah, so like Chandresh say that 5G is here, right? So I think our multi-node server, like BigTwin or Twin Pro, we are ready for the 5G. Other than the data center itself, we can also use the 5G kind of edge computing. Also, we also have some application can run in our BigTwin system as well. So I believe that for the coming few years, our multi-node server will be in 5G platform, 5G market. That can be a very good candidate to fulfill to this market.
Okay. Michael, any parting thoughts?
Yeah, I think in general for 5G with the need for more performance, I think the reference solution really speaks for itself. And just to kind of summarize what we've seen during this session is that, we can deliver, a lot of performance in this multi-node system, but, commodity hardware can really help accelerate this. So in partnership with Intel, we're ready, as Bill mentioned, to really help accelerate things, especially with the partnerships that we have with ASTRI, as well as Red Hat and other container solutions, even with Canonical. So I think we have a lot of things to offer to the market, and we're excited for the future.
Great. Thank you very much, guys. Really appreciate joining this panel and sharing your vision and the solution, as well as where you see the market is going to, evolve and how we can be part of it. Really appreciate it. Thank you.
Thank you.